Welcome everybody. These are the notes for Chapter 8, Day 4. And in these videos, we're going to take a look at applications of integration. So we're not really going to do anything new, but we're going to take stuff that we've learned and apply it to different problems. What we have to start is an example of an FRQ. This is from 2011. It is a non-calculator FRQ. So you can take a look and see there's four parts. There's four parts, A, B, C, and D. That go with the given information. I would recommend you guys pause the video and see what you come up with on your own. And given the test, you'd get about 15 minutes to do this problem. All right, if we get started, we want to read the question carefully. So let f be the continuous function defined on the closed interval -4 to 3, whose graph consisting of line segments and semicircles and the semicircle centered at the origin as shown in the graph. Let g be the function given by g of x is the integral from 1 to x of f of t dt. So you want to make sure you know the relationship between the functions they talk about, the graph you're given, and so forth. So this is the graph of f, right? It's f of t, f of x, it's f. We know that g of x is the integral of from 1 to x of f of t dt. So when you look at part A, it's really just using that relationship. If we want to find g of 2, then we're going to simply plug into the integral from 1 to 2 of f of t dt. Given this problem, there is no function to integrate, so we're going to have to evaluate that integral using the graph, which that means that the integral is going to be represented by the area between the curve and the x-axis. So looking at this from 1 to 2, we're starting at 1, 2 is going to be here. So really, we want to know what is the area of that triangle right there. But also, we have to take into account that the area is below the x-axis. So we're going to get a negative value. -1/2. Now, the base of the triangle goes from 1 to 2, so we're going to call that 1. We need to know the height of the triangle. And if you look at the segment in general, basically you have a rise of -1 and a run of 2. So you've got a slope of -1/2, which means if we go over 1, we're going to go down 1/2, which means the height at 2 is 1/2. If we multiply that out, -1/2 times 1 times 1/2 is -1/4. And that's how we can find g of 2. Now for g of -2, again, it's just an application of that function, so we can write it as the integral from 1 to -2 of f of t dt. Now from there, usually when you take an integral, you want it to go, your limits of integration to go from the smaller number to the bigger number. If we were to rearrange this and rewrite this from -2 to 1, then we need to change the sign by basically putting a negative in front. So it's going to be the opposite of that integral. And if you write it that way, you can look at the graph from left to right and still interpret it as when the area is above the x-axis, it's positive. When it's below, it's negative. And then that negative in front will take care of all the signs from going the other way. All right, so now if we take a look at this, we've got that negative. Now, starting at -2, from -2 to 1, the integral is going to be represented by that area. And then from -1 to +1, it's going to be represented by that area. So we're going to have to find those. So the triangle is going to have an area of 1/2. The base is 1. The height is 3. And then the semicircle is below the x-axis, so it's going to be minus. It's half of a circle, so 1/2 pi times 1 squared. All right, if we simplify from there, we've got that negative in front. 1/2 times 1 times 3 is 3/2 minus, and then 1 squared is 1 times 1/2 times pi is going to basically be pi over 2. Now, that answer would be perfectly fine to get you full credit on the AP exam, but if we go through, distribute the negative, it's going to become negative 3/2 plus pi over 2, which you could write as pi minus 3 over 2, which is another way to write that answer. All right, so that's how you would do A based on that. Now, when you take a look at part B, you'll notice that part B wants us to find g prime of negative 3 and also g double prime of negative 3. What I would do is I would figure out, okay, how does g prime relate to the graph of this function? So using that relationship above, we would know that g prime of x is going to be the derivative of the integral 1 to x of f of t dt. Now, hopefully you recognize that that is the second fundamental theorem of calculus, and when we apply it, g prime of x is simply f of x. So this graph is the derivative of g, basically. So then using that, when I go to evaluate g prime of 3, that's going to be the same thing as f of 3. And all I got to do is go to the graph, find, oh sorry, that was negative 3, excuse me. All right, is we got to go to the graph and figure out what is the height of the function at negative 3. So that's going to be represented by this point here. Now to do that, we're dealing with the segment, so you probably want to figure out, okay, what is the total, what is the slope basically? Well, we're going from from 1 to 3, which is rising 2. We're going from negative 4 to negative 2, which is a run of 2, which basically means our slope is 1. So if we go up 1, we're going over 1. So this coordinate would be negative 3, 2, and that would make g prime of negative 3, 2. From there, we are also asked to find g double prime of negative 3, which is the same thing as f prime of negative 3. So given the graph, in order to identify the derivative of f, we need the slope of the tangent line at the point. We're dealing with a segment, so the slope of the tangent line will be the same as the slope of the segment, which makes it 1. And that's how we go about finding g prime of negative 3 and g double prime of negative 3. Moving to part C, it says find the x-coordinate for each point where the graph of g has a horizontal tangent line. For each of these points, determine whether g has a relative minimum, a relative maximum, or neither a relative minimum or maximum point. Justify your answer. So what I'm thinking here is g has a horizontal tangent when g prime equals 0. All right, which basically means so when f equals 0, because as we stated above, g prime of x equals f of x. Okay, so this happens when, all right, so we could say that g prime of x, which is equal to f of x, is equal to 0 when x equals, well, all we got to do is look at the graph and see that it's at negative 1 and positive 1. So when x equals negative 1 and x equals positive 1. Now the other thing the graph is wanting us to identify is if it's a relative minimum or relative maximum, or neither. So g prime of negative 1 is a. Well, when you go to look at the graph, again, this graph represents the derivative of g. So at negative 1, the derivative is changing signs from positive to negative. That makes g prime, that makes negative 1 a relative maximum. So g prime, g of negative 1 is a relative max because g prime of negative 1 changes signs from positive, well, let's go ahead and write it out, from positive to negative. And then if we go and we take a look at 1, what's going on at 1? Well, G prime doesn't change signs at 1, okay? So basically what that means is that G of 1 is neither a relative min or relative max because G prime of 1 does not change signs. Okay. So there's a few different parts there. I always like to start out with kind of the reasoning of what I'm looking for. It just helps me kind of get that straight in my head before I answer the question. All right, and then if we take a look at part D, it says for x greater than -4 and less than 3, we want to find all values of x for which G has a point of inflection. Explain your reasoning. So what I'm thinking of, okay, well, what do I know about points of inflection? What you should remember is that a function has a point of inflection when its second derivative is 0 or undefined and changes signs. So I'm going to go ahead and just start with that. So G has a point of inflection when G double prime equals 0 or is undefined and changes signs. Or another way to identify points of inflection has to do with the derivative. All right, so or when the derivative of G has a relative extrema. All right, those are the two ways that you can identify points of inflection depending on what you're looking at. The reason that I added that second piece there is because earlier in the problem, we identified that this graph f of x is the derivative of G. So it's much easier to just try to figure out, okay, where does this graph have a relative extrema? And we are going to have a relative extrema at this point, so when x equals 2, at this point when x equals 0, and at this point when x equals 1. All right? So you could kind of finish this and say that G prime, which is equal to f, has relative extrema when x equals -2, x equals 0, and x equals, I think it was 1 if I remember correctly. Yes, 1. All right, so G prime, which is f, has relative extrema when x equals -2, x equals 0, and x equals 1, which are points of inflection of G. All right, so that gives you guys an example of what an FRQ might look like involving integration. Now, if you look below, this is what the scoring rubric would look like for that question on an AP exam. So I'd encourage you to take a little bit of time to kind of read through this and see what they have. So you've got the work on the left side, and then you've got basically the point breakdown on the right side. So part A was worth 2 points, 1 for G of 2, 1 for G of -2. Part B was worth 2 points, 1 point for G prime of -3, 1 point for G double prime of -3. Part C was worth 3 points, 1 for identifying essentially critical values, so when the derivative was 0, 1 point for identifying those values, and then 1 point for your answer with justifications. And then part D was 2 points, 1 for your answer, and then 1 for your explanation. You have to make sure you give complete answers to get all these points. And then the other thing I should probably mention real quick is that every single FRQ on the AP exam will be worth 9 points. So some will have 3 parts, some will have 4 parts, but no matter what, every FRQ question will be worth 9 total points. All right, guys, I'm going to go ahead and end part 1 of the video here. Make sure you check out part 2, going over the other examples.